Hi, my name's Dave. In this video, I show you how I convert a regular pedal bike into an electric bike. Conversion will save you about $2,000. And in the end, you'll have an e-bike which is every bit as good and performs just as well as a retail e-bike. So from a cost perspective, it's certainly worth considering. It's a relatively simple process. Anyone can do it. It takes about 2 hours. But as with anything simple, there are things you'll need to know so that your simple process doesn't become a big disaster. And this video goes over those potential pitfalls. Disclaimer: this video is a courtesy, not an official training program. I am not liable for damage or injury. You're on your own. That having been said, I've built 68 e-bikes in the last 3 years. None of them have burst into flames, and none of the riders have been injured. So chances are you'll be fine. So let's get this show on the road, shall we? Okay, more on project preparation. The bike you plan to convert must be made from steel or aluminum only. You cannot convert a bike made with carbon fiber frames or titanium or alloys. They cannot withstand the torque of an e-bike motor. Eventually, and usually pretty quickly, the forks will shatter. So, steel or aluminum only. And fortunately, most mountain bikes, cruisers, comfort bikes, and hybrids are made from steel or aluminum. But check it out. Make sure you know what your bike material is, and make sure it's steel or aluminum. Okay, now, the next thing on our list is the all-important torque arm. This is a torque arm. This little device costs $10. You absolutely, positively must have it on your bike. Without it, over time, your dropouts will split. And if that happens while you're riding, you will suffer personal injury and you'll ruin the bike. So, $10, get one. Order it at the same time you order your motor so that you have it on hand when you begin your project. Another item that you'll need to buy are these horseshoe washers. These are designed specifically for e-bike axles. They're used to take up any gaps between the motor and the dropout, and they're also used to fill in the what they call the lawyer lip cavities. They cost $5 for 2, so get a half dozen and order them at the same time you order your motor so that you have them on hand when you begin your project. We certainly don't want you having experiencing any delays. Okay, before getting into the actual assembly, let's go over project preparation. Things you'll need to know in order to have a successful outcome. And the first thing on our list is dropout spacing. This slot into which the axle fits is known as the dropout. Dropout spacing is measured from the inside of one dropout to the inside of the other. Why is this important? Well, e-bike motors have a minimum spacing requirement in order to fit into the frame. The motors I buy have a minimum dropout spacing requirement of 3.6 inches. So let's measure this bike and see where we stand. This bike measures 3.945, which is greater than 3.6. So we're ready to roll. Fortunately, most mountain bikes, cruisers, comfort bikes, and hybrids have dropout spacing wide enough for e-bike motors. But don't make any assumptions. Take the measurement to be certain and buy a motor which fits your bike, or buy a bike which fits your motor. Okay, a few more items on our project preparation list. First up, motor specs. What kind of motor should you buy? I always recommend 48 volt 1000 watt motors. They're powerful and fast, top speed 30 miles per hour, and they climb steep hills and cut through strong winds with ease. Next up, wheel size. E-bike motors are readily available in the United States for 26-inch bikes. They cost under $300 and they arrive in 2 to 3 days. If you have a 27.5, 700C or 29-inch bike and you want a motor that perfectly fits, you'll probably have to order that from China. The price will be double, the shipping will cost as much as the motor, and the wait will be very long, 6 to 10 weeks. In most parts of the country, riding season will be over before your motor arrives. It is possible to put a 26-inch motor on a 27.5 or 700C bike. Looks fine and works fine, but the brakes might be an issue. With rim brakes, you might not have enough adjustability in the pad slots for the pads to properly align to the rim. And in the case of disc brakes, you might not have enough adjustability in the caliper to get the rotor concentric with the pads. Many times you can find a way to make it work, and in some cases you'll have to break out the Dremel tool. And in the worst case scenario, you'll need to live without front brakes. Not ideal, but it is an option. If possible, stick to 26-inch bikes. Next up, battery pack. The battery pack is the most expensive and critical component in your e-bike. Head over to the e-bike forums and get yourself an education, and you'll discover what the rest of us in the e-bike world know. Specifically, that the best lithium-ion cell for general e-bike applications is the Panasonic NCR 18650GA. Nothing else compares, so nothing else is worth buying. Insist upon GA cells. Your pack voltage must match your motor voltage. If you buy a 48-volt motor, then the pack must also be 48 volts. Regarding the amp hour rating of the pack, I recommend 17 or 20 amp hours. This will give you plenty of range, generally 50 to 70 miles between charges. Purchase your battery pack at the same time you order your motor so that you have it on hand when you start to build your e-bike. Now we head over to the internet and I'll show you where you can buy all these things. Where to buy the stuff? Motors. You can shop around on eBay or Amazon, or you can go to different e-bike component retailers. I use eBay and sometimes I use Amazon. And you can find a lot of different options. You type in the search string 48 volt 1000 watt e-bike conversion kit and you will get page after page after page of options. Let's pick one. Where's one that has that meter? Oh, right here. Alright, this is your typical e-bike motor. There's the beautiful SW900 meter that I talked about. And there's all kinds of information on here, and you do all your research, do your homework, check out the, what kind of a seller is he a good seller, etc. And then go with your best instinct. Now I want to talk about dropout spacing. Remember we went over this earlier in the video, and these people are saying that you need a minimum dropout spacing of 3.94 inches. I don't believe that. This is the same motor I buy, and I find that they need 3.6 inches. But anyway, most bikes have got about 4 inches anyway. So that's it. Amazon, eBay, and there are some other, there are some bike companies, e-bike companies around, local ones. There are some nationwide ones. We'll get into some of that now. The place where I buy my torque arms is a company called Ebike Ling, L-I-N-G. And, well, there's the torque arm right there. $10.99. Extremely important. Make sure you get one. Order it at the same time you order your motor. And that's it, Ebike Ling. They also sell battery packs, motors, and a whole bunch of other e-bike accessories if you're interested. Now I buy my horseshoe washers from a company called E-Bike Kit. They also sell the torque arm. It's here, a little higher than Ebike Ling, but here's the horseshoe washers, or they call them the C washers, $5 for 2. Get yourself a half a dozen. Order them the same time you order your motor, so you have them ready and available when you build your bike. Okay, and so that's where you buy the stuff. And you're probably asking yourself, hey, Dave, how come you haven't shown us any battery packs? Well, there's a reason for that. The reason is that most, if not all, of the battery packs available out there are not worthy of my recommendation, quite frankly. Most of them, if not all, are manufactured in China. They're made from junk cells and junk parts, and they have a lot of design flaws, and the warranties are either useless or non-existent. So I always recommend to people, if you can invest in a welding machine, build your own battery pack like I do. If you don't have that technical expertise and you don't want to invest, you can always buy a battery pack from me. Your third option is to hunt around online, read reviews, check things out, do your homework, and take your chances with what's available out there. And that's it. I'd like to give you a shining report about, hey, you can get battery packs here, there, and the other place. Well, you can, but do you want them to last more than 1 year? Do you want them to not catch on fire? In that case, like I said, your options are build your own, buy one from me, or do your homework and make your best purchase. That's it. Where to buy the stuff. Okay, whenever you buy things online these days, there's always that section in the ad that asks the relevant question, what's in the box? So here's an e-bike motor I just bought, and let's find out what's in the box. First of all, they give you this little rubber band, which you have to put inside the rim so that your tube doesn't get punctured. And then they also give you a tube. And there's something I want to explain about this tube. You'll notice that the valve stem is very long, and there's a reason for that. The motor rim is double walled, and so it requires a long stem valve. And if you so you have to use this tube, not your original tube. And if you plan to buy a spare tube and keep it with you like I do, make sure you buy a long valve stem tube. I think they're 40 millimeters, or you can use valve extenders. All right, so that's the tube. They give you a case for your motor controller. They give you a mountain bike tire. Very accommodating of them. I don't use these because I prefer to have my front and rear tires match. But anyway, they give you a tire. And then what those people do is they put a box inside the box. And inside this box are several other important items. The instruction manual, you'll need that. This is the pedal assist sensor. I don't use pedal assist. I'm a throttle guy. But if you want to use pedal assist, you can read the instruction manual on how to install this. That's the pedal assist sensor. Here's the throttle. They also give you these kill switch brake levers. And I recommend that you use at least one of these on your bike. It's always nice to have a kill switch. This is your motor controller. And we'll be going over this at length. This is the brains of your e-bike. And like I said, we'll go over this at length, how to connect it and what it all means later on in the video. Then they put a box inside the box inside the box. And in this box, you will find the SW900 meter. Now this device, I highly recommend this. You can buy a motor that doesn't come with a meter and you'll save $50. However, I strongly recommend that you get this. It has several useful functions. It's a speedometer, odometer, tripometer. It's a battery level indicator. It tells you how many watts you're running at certain speeds. And lastly, it has self-diagnostic capability and gives you error messages, which helps you isolate problems in the system. So I highly recommend that you get this. That's the SW900 meter. Now, last but not least, is our beautiful, shiny, new, powerful, and silent e-bike motor. And that's it. That is what's in the box. Okay, conversion time. First, we're going to be smart and do a bench test of all the components. There's all the components down there. So you put the rubber band in the rim, put the tube and the tire in the rim, put the motor into the bike, tighten the nuts. Because when you hit the throttle, if those nuts aren't tight, the motor could come flying out of the bike. We don't want that. Alright, now, components. Look at all that spaghetti. It's very simple. Don't be intimidated. Now here we have our SW900 meter and our throttle, motor controller, and battery. That's all we need. Oh, and the motor, of course. Now all these connectors are color-coded and all of the connectors are unique, so you can't possibly make a mistake. Let's talk about the motor first. Here's the motor wire. It has 3 power wires, green, blue, and yellow. And they go to the green, blue, and yellow coming out of the controller. Motor also has a hall sensor, and that connector is unique. So you plug in the hall sensor. Now you have your throttle, color-coded, and unique connector, and then the SW900 meter, color-coded, and unique connector. Finally, you've got your battery pack, and red and black. Make sure you don't reverse those. Very important. Okay, we're ready for the bench test. Now when we bench test, we're making sure that all of our components work. And there's one more. Let's turn the SW900 meter on. Okay, ready to roll. And we're checking also motor rotation. The motor is not marked with the rotation. When you bench test, you want the motor to spin, the tire to spin toward the back of the bike. Okay, everything's connected. Let's give this throttle a twist and find out if that motor is spinning toward the back of the bike. No, it's spinning toward the front of the bike. It's backwards. How do we fix that? Well, that's simple. I'll show you. All you do is spin the motor around. Tighten those nuts back up. Let's see if that fixed the problem. Oh yes, now we're spinning toward the back of the bike. That's exactly what we want. Our bench test is complete. All systems go. One more thing I want to point out to you. Tricks of the trade. You'll notice that I use wire nuts for the motor power wires and the battery connection. There's a reason for that. When you get your motor and your motor controller, they come with these stainless steel connectors. These are no good. They act like a current bottleneck. They create tremendous amounts of heat. The insulation melts after a while, and you could get a short circuit. So, cut those off, strip the wires back, and go with standard wire nuts. And that's it. Our bench test is complete. Let's finish this bike. Okay, now we're going to discuss how to correctly fasten your motor to the bike. First thing I want to discuss is, here's your motor power wire, and you'll notice that this wire can bend in this direction toward the handlebars. That's what you want. There is actually a groove cut into the axle to allow that to happen. You don't want this wire, you don't want the groove facing this way and the wire bending up. You want the wire bending down toward the handlebars. So make sure that you orient the motor so that the groove is facing down toward the handlebars. That's number one. Number two, you're going to notice I have a washer here between the dropout and the motor. And that's because the motor, there was a little bit of a gap. The motor had a little bit of lateral movement, and we don't want that. So we take that up with washers. I put one on each side, and now the motor is the same width as the fork. If you have a gap and you don't take the space up with washers, then when you tighten the nuts, you're going to be bending your fork, and we don't want that. Okay, so with that said, there's another thing we need to know, and that is the camera probably won't pick this up too well, but most bikes have a circular indentation on the outside of the dropout, and they call that the lawyer lip. We need to make that flush with one of our horseshoe washers. Okay, so that's all flush now. If you don't do that, if you have a lawyer lip and you don't put a horseshoe washer in there to make it flush, then when you tighten the nuts, the motor is going to creep out of the axle. We don't want that, obviously. So that's it for this side. We're going to put all the hardware on now. And move over to the other side of the bike. Okay, on the other side of the motor, the process is similar in many ways, but with one very important added step. So, as you can see, I have that washer in between the motor and the inside of the fork to take up the gap. And I have a lawyer lip, that circular indentation. I fill that in with a horseshoe washer. And now we have to talk about our torque arm, good old torque arm. Now, there's something very important about the torque arm that you need to know, and that is where it's striking the fork. As you can see, we want this in the center, but it's offset. It's too close to the inside of the fork. So we're going to add some washers to get this torque arm right in the middle of our fork. Oh, much better, much better. Now we're striking the center of the fork and we're not off to one side or the other. Another thing I want you to notice about this torque arm, the contact point is the front of the fork, not the back. You install your torque arm with it facing the front of the fork, okay? With that all done, pretty much ready to tighten this bike up. And when you do that, you go a half turn on one side, half turn on the other, and keep repeating that process until it's good and snug. And make sure that your motor is not riding up into the fork. It shouldn't if you use the horseshoe washers for the lawyer lips. Tighten that up really good. And then, check out your torque arm. Get it right up against the fork. And then tighten that up super tight. And that's it. That is the correct method of fastening your motor to your bike. Okay, with your motor properly fastened to the bike, the rest of the process is relatively simple and straightforward. Connect your throttle to the handlebars. Connect your SW900 meter and the off-on switch to the handlebars. Connect your kill switch to the handlebars. Take all these wires and dress them nice and neat. And the motor wire, you're going to notice that there's a loop here. I call that the service loop. The reason that's there is if you have to change a tube or a tire, there's enough slack so that you can drop the motor out of the dropouts to work on it without having to disconnect all of your wiring and reconnect it. And then dress all the wires nice and neat all the way back to the sack which holds your motor controller, and attach your battery, and you're ready to go. Before we conclude this video, we're going to take one more trip back to that all-important torque arm. Okay, back to the all-important torque arm. Before you take your bike for a ride, what you want to do is you want to make sure that, remember we talked about the torque arm should be contacting the front of your fork and not the back, the front. So check your orientation and make sure you're contacting the front of the fork. Also, make sure that the torque arm itself is in contact with the fork. You should not even be able to get a fingernail between that torque arm and the fork. And once you've got everything in the correct position, tighten this hardware up super tight. And then take a small ride at about 10 miles an hour, very short distance. Then get off and check everything again, and if necessary, tap it up against the fork, tighten up the screws again. And then take another ride at about 20 miles an hour, a little bit longer, check it again. And once you're satisfied that it's stable, you can ride pretty comfortably. But I would say in the first week that you have your bike, check your torque arm before you ride, every time that you ride. And then thereafter, check it every week. And when you're satisfied that it never moves, then you can stop checking it. And that's it. That torque arm, very important. Pay attention to it. Also, if you have to change a tube or a tire, make sure you take a photograph of how that torque arm goes onto your bike with your cell phone, so that when you put the bike back together, you know what to do. That's it. I hope you found this video useful and helpful. Thank you for watching, and happy riding.